Good morning, everybody. This is Joe with Carbon Marine. Today, we're going to talk about the most important advice to not ruin the assembly of your push-pull if you ordered a push-pull from us in a build-to-ship configuration. What does that mean? In simple terms, it means we sell push-pulls outside of our geographical delivery area. We deliver from the Panhandle to Charleston to Key West. That's the majority of the market for push-pulls. But there are a lot of places throughout the world that use push-pulls, and it's difficult to get a fully assembled or a one-piece push-pull to these remote locations. For example, the Seychelles Islands in the Indian Ocean. We send them to Asia. We send them to Central America around Quintana Roo, Mexico, and Tulum. There's a bunch of permit lodges down there, and you just can't take a one-piece push-pull into these remote locations. So we came up with a concept called build to ship, and all that means is we bond the tip, we bond the foot, and we bond the ferrule into one side or the other of the joint to make the push-pull as fully assembled as we can get it and still put it inside of, say, a 70 to a 90-inch box and ship it UPS or FedEx. We prefer UPS. So the pitfall that some people, the trap that some people fall into when they're assembling their build to ship is they don't properly compress or keep the sections together while they're curing. And it gets a little into the weeds here, but I'm going to take a minute to explain it. And you've heard me use this term before, but basically it's a physics principle, Boyle's law. A fellow named Boyle's come up with the observation that pressure, temperature, and volume are all related. So if you have a tube and it's got air in it and it's compressed or it's at a stable state and that tube gets warm, it's either got to increase the volume or it's got to increase the pressure. Well, in terms of a push-pull, if you're increasing the volume, that means the sections are separating. That's not what you want. That's horrible. You're not going to be happy with the results, and it's not going to be appropriate or the best case scenario. So how do you avoid that? I've got two simple tricks to show you here on camera how to avoid that. One is if you're in more of a controlled environment, like say in our shop, how we keep the sections together when we bond multi-piece push-pulls. And we'll call that the clamp and rubber band method. So the clamp and rubber band method, forgive the clamps, these things have been here for, 15 years, they're kind of weathered. But the clamp and rubber band method's pretty simple. We put down a piece of paper towel so the metal clamp doesn't scratch, even though there are these little plastic boots. Sometimes these boots get worn or in this case, they're missing. So I put down a little piece of paper towel. This is a 2-inch spring clamp. You can get these things for 99 cents on sale at Home Depot. If you don't have a half a dozen or a dozen of these things laying around your garage, you're missing a great tool. We use them for all kinds of stuff, but they're really, really valuable to us, specifically for push-pull assembly. And secondly, just large rubber bands. And what will happen is when you put that ferrule in the middle here, and you get the sections together with epoxy on the inside, this compression between these rubber bands and clamps, the clamps just are anchor points for the rubber bands. They don't they don't change the shape of the tubing. But when you put those rubber bands on there, that tube is now as tight together as it can be, and you'll get a little bit of residual epoxy leaking out here. You just wipe that out. Just wipe that off. Come back in about 5 minutes or so and check it again, because as the epoxy begins to set, it'll get a little warmer, and it'll kind of push out with the exotherm or increase in temperature. But just check that periodically. But this is our preferred way to do it. This is how we assemble push-pulls in our shop. All right? So we call that the clamp and rubber band method. Very effective. Now, if you're not a professional push-pull builder and you don't have clamps and rubber bands, a good old roll of electrical tape. Now, I know this is kind of busy and it's a hot mess and you can't really tell what's going on here, but I'm going to describe it. I made the choice to wrap this because it's a little easier to do when you're filming by yourself, as I am today. So same concept, the ferrule's in the middle. We wipe the epoxy out. We'll put one wrap of the tape over the joint. The joint is actually here. And that's to keep a nice uniform finish in the event the epoxy wants to weep out or leak out or get pushed out with the exotherm as it cures. And then the next thing we do is we start here with a roll of We start here with a roll of electrical tape. I use white so you can see it. You can use black, color's irrelevant. And you're basically gonna put a tag in down and you're gonna wrap, you're gonna rotate that tube and you're gonna go about 4 inches. It's about 4 inches from the center of the joint to where we put the tape down. That's important because you need that tape, that contact. And then as you're pulling and rolling, you're stretching that tape a little bit. Don't get crazy because you'll break the tape, but you want that tape stretched a little bit, and you're basically making figure eights. And you can see that here. So you're just pulling that tape, you're coming up, and then you're doing a hard turn, and you're coming back, and we did it 3 times on this one. And if you go down, around, and back, and rotate it a little bit more, down and around and back, you're gonna get a pretty symmetrical distribution of that tape on both sides of that joint, and that tape stretched. And now that tape is gonna apply compression and keep those 2 sections together while it cures. I've used this in the field, I've used this on the side of the roads, fixing push poles for people, in their yards. I mean, this is a tried and true way to permanently, I shouldn't say permanently, to hold these sections together while it permanently bonds. But when I explain this to people on the telephone, they get really perplexed. They're like, huh? Figure 8, tape, wrap, round. Like, they got to see it. So that's why I wanted to demonstrate, here on camera. That's what it looks like when it's done. But let's say you're going to start. Get your tag in. Don't go crazy. You don't want to go around like this. You want to go linear. You want about a 10 or 15 degree, and you're just going to roll, turn, come back, turn, come back, turn. And you're going to do that 3 times with tension on that tape. And then in 2 or 3 hours, once everything's cured, you just come back and peel the tape off, and you're going to have an amazing joint. The sections are going to be butted up together, and you will have avoided ruining your bond on your multi-piece build-to-ship push-pull from Carbon Marine. One other point I want to take a note of here and explaining this is epoxies come in a whole variety of cure times. That's really important in Florida or anywhere where it becomes tropical. Typically, this is tarpon season, beginning of April, and it's starting to get warm, especially if you're in the sun. You never want to assemble or work with epoxies in direct sunlight, especially with objects that are black, because black objects pick up radiant heat from the sun and they get really, really hot. And that heat accelerates the cure. So just for reference, all of the cited cure times or pot lives that you'll see on epoxy-based products or epoxy adhesives will give you a quote pot life. And all that pot life is describing is how much time you have to work with that epoxy before it goes semi-green or gets so thick that you can't use it anymore. It's cured. And that pot life is dramatically impacted by temperature. The quoted pot life for one of the epoxies that we use is 15 minutes. That's pretty fast. That's 15 minutes at 77 degrees Fahrenheit. For every 7-degree increase in the air temperature, that pot life gets cut in half. So if it's 87, that pot life is 15 by half, 7.5 by half. Now you're down to 2 or 3 minutes. It can get really, really dicey if you're putting together a pole that's got 2 or 3 ferrules. You got to move and move fast. So it's not an easy solution. We're trying to find, the Goldilocks epoxy that's, doesn't take forever, but doesn't cure in 5 minutes because it's just not enough working time. But that's really important to note when you are going to build one of these build-to-ships. You get everything absolutely ready to go. Turn your phone off, lock the door, put the dog out, put down the adult beverage, focus on what you're doing, and do everything that you need to do. Have all the pieces indexed, laid out close to each other, be rock and roll ready. So when you mix that epoxy and you wet out that male ferrule and you slide it in and you rotate it and you wipe the excess off, Go to the next one. Don't do all the taping. Don't do all of that right then. Go to the next one, because the epoxy, as it's curing, it's giving off heat. So it's heating itself, which then again accelerates how fast that epoxy will cure. So you work diligently, you work smartly, but you stay cognizant of the time, and preferably you can do this in the shade or somewhere air conditioned where you're at 75, 70, 77. I don't like doing it in temperatures that are higher than that unless it's a really, really slow epoxy, because it will sneak up on you. It'll go from flexible, spreadable to hard in seconds. So just one of the perils of working with epoxy in high temperature environments. But it's Joe with Carbon Marine. You can find us at carbonmarine.com. You're always welcome to call me at the office, 813-284-7040. There's no question about push-pull assemblies, push-pull design, push-pull length, push-pull types. There's no question that I can't answer for you, and be glad to. Thank you.